You can use sign conventions to tackle most of the lens and mirrors questions on the MCAT. For all of those problems, the object distance is always positive. A negative image distance means it's a virtual image, and a positive image distance means it's a real image. For mirrors, if we assume the object is on the left side, then a positive image distance means the image is showing up on the left side, and a negative image distance means it's showing up on the right side. And that's for both converging and diverging mirrors. Converging mirrors have a positive focal length, and the focal point is on the left side of the mirror, while diverging lenses have a negative focal length, and the focal point is on the right side of the mirror. And make sure you understand that using the terms right and left is all dependent on the mirrors looking like this, and if the mirrors flip their orientation, then the location of everything else also flips. The sign conventions are very important because if they tell you that you have a diverging lens with a focal length of 5, then you need to be plugging in -5 to your thin lens equation. If you memorize your sign conventions, then anytime a question requires the thin lens equation, you just plug the numbers into that equation and find the missing value. And in addition to the thin lens equation, this magnification equation is also incredibly useful. Whether you are given the object distance or the image distance, just plug in the missing value, and then you'll be told the size of the image relative to the object. If your final value has a negative sign, then your image is inverted. If it has a positive sign, then your image is upright. And you can also use these equations to solve problems that don't give you actual values, which we have in this example below. Here they tell us that a concave mirror forms an image that is real in the same size as the object. Where is the object located relative to the mirror? Since we're told that the image and the object are the same size, that means that m is equal to 1, so I equals O. And for our purposes, you can ignore the negative sign right now because that just tells us if the image is inverted or upright, but all we care about right now is the magnitude. So once we establish that I is equal to O, we can set up our thin lens equation. So we have 1 over F is equal to 1 over O plus 1 over I. And since we're not given actual values, a lot of places are going to recommend that you take an algebraic approach and solve this using variables. But what I would recommend is that you make up fake values that match the situation described. We're told that I equals O, so we can just plug in the same value for I and O, and you can choose any value that you want. I'm going to use 1 just to make it simple, so we have 1 over 1 plus 1 over 1. So that means 1 over F is equal to 2, and when we solve for F, we get F equals 1/2. We can then compare the distances that we used for the object, the image, and what we found for the focal length to see which answer option matches what we found. And we found that the object is a distance of 1 away, while the focal length is a distance of 1/2 away. So that means our object is placed beyond the focal length.